Alright, so the research question we were trying to answer is which ion is present in a sample of water. So we were given the ions sulfate, phosphate, chlorine, and iodide, and so we were trying to figure out which one of those four were present in a sample of water. And our second research question is which filter would do the best job in filtering out the ions. So we were trying to figure out if it was going to be our own filter, the coffee filter, or the Brita filter. And that's our question.
So we're adding solution H to each of the filter solutions. So we're gonna add it to Brita right now. Oh, psych.
Nope.
Ooh, wow.
That's a lot of cream.
And what happened to the first one? Looks like the same. Filter. That was the coffee.
Alright, so for our filter, we're going to use a red soda cup. We put holes in the bottom so that the water can filter through. So first we're going to use some sand and just put it in. It's like a base layer. And then we're going to have some coarse rocks and put those in. And then for our final layer, we're going to have charcoal. So some big pieces of charcoal, which we're just going to break down, put in. And yeah, hopefully this will filter out our ion.
So here we have the weight of each filter. So for our homemade filter, obviously, as we explained before, it was unsuccessful as we couldn't actually filter anything out. And for our unfiltered total filter weight, it was 1.71 grams. For our coffee filter, it was 1.66 grams. And for our Brita filter, it was 1.63 grams. So simply to calculate the weight of the ions that was filtered out, we can subtract the filtered weight from the coffee filter and the Brita filter from the unfiltered total weight. So here for the coffee filter, we subtract 1.66 grams from 1.71 grams to get 0.05 grams. And for the Brita filter, we do the same thing and we get 0.08 grams. So this shows that the Brita filter filtered out more ions than the coffee filter.
How's it going, guys? John Bell here to explain why our filter here kind of sucks. So as you see, we didn't get any water, just a lot of sand, and that's because we used way too much materials. Next time, we're gonna use less, same materials because they're still pretty filtered, but less. Thank you.
Yeah.
In regards to my group's filter, it was not effective in removing any ions present in the water. This is because my group put far too many items in the filter. As the solution was added, it was absorbed by the materials in our filter, and no filtered solution came out. Therefore, our filter was quite ineffective, as it was unable to filter the solution. It cannot be compared to any other methods, as no filtered solution was obtained. To do this, my group designed a flowchart using the precipitating solutions available in the lab. We added 3 different precipitating solutions to small portions of the original solution. The precipitating solutions were chosen so that they would only precipitate one of the unknown ions. Due to this, my group did not use barium nitrate, as it would have precipitated both sulfate and phosphate. After several tests, we discovered that the addition of lead nitrate resulted in a white precipitate. Therefore, we concluded that chlorine was the unknown ion. Unfortunately, after verification, we discovered that the unknown ion was actually sulfate rather than chlorine. However, when calcium nitrate was added, no precipitate formed. This led us to believe that our original solution was contaminated. The second conclusion we drew from this lab was that the Brita filter was the most effective in filtering out the ions. In this lab, this most effective filter would have filtered out the most ions from the original solution. In doing so, the filter solution would have limited ions remaining, as the majority have already been filtered out. Thus, when the filter solutions were put through filter paper, the most effective filter would result in a precipitate with the smallest mass. After some calculations, we discovered that the Brita filter was the most effective, as it resulted in a precipitate with the smallest mass of 0.53 grams. Based on our data and calculations, my group was able to draw 2 main conclusions from this lab. Firstly, my group concluded that chlorine was the ion present in the water sample. Due to the fact that our unknown ion was an anion, we were left with only one method to help identify this unknown ion. This is because flame tests and solution color tests are only prevalent for identifying unknown cations. Therefore, we utilized the precipitation method.